Greetings everyone, and welcome to part 2 of Revolution of Reality. In part 1, I discussed why telepathy experiments could soon bring about a revolution in physics and a transformation in society. This may sound really far-fetched, because based on the standard high school education, telepathy should not be possible at all. However, school physics is based on physics as it was about 100 years ago. It shields us from all the shocking developments that have taken place since the early 1900s. So in this episode, we'll take a look at some of these shocking developments and why telepathy is so much more plausible if we go beyond school physics. At school, I learned a version of physics that seemed very clear and complete. I learned how all the elements in our world and all the objects in our world are formed from just 3 basic particles: electrons, protons, and neutrons. I naturally assumed that the fundamentals of physics had been completely figured out by physicists. So it came as quite a shock when I later found out that the fundamentals of physics, as contained in quantum theory, are in fact still not understood. Over the years, our understanding of the atom has evolved through a number of different models. Each consecutive model was found to have deficiencies and was thus replaced by a new model based on new discoveries and a new theory. The current model of the atom, called the quantum model, came into effect nearly 100 years ago in 1926. The quantum model was known to be deficient from the outset, since, for example, it didn't include one of the 4 forces of nature, gravity. A number of other deficiencies have cropped up over the years. In contemporary articles, the quantum world is described as strange and confusing, with a reputation for weirdness. For example, it seems to imply that particles are in many places at once, something we would regard as physically impossible. In fact, the laws of the quantum model seem impossible, according to theoretical physicist Brian Greene in his popular series The Fabric of the Cosmos. Here's the introduction to part 3.
Coming up, the realm of tiny atoms and particles, the quantum realm. The laws here seem impossible.
There's a sense in which things don't like to be tied down to just one location.
Yet they're vital to everything in the universe.
Quite understandably, this strange, confusing, not understood, and seemingly impossible model of the atom is not taught in school. Instead, the planetary model has been held out of retirement as a teaching aid for children. It's ideal for the job. It's clear, simple, and relatable, since it behaves like a mini solar system. In my school years, the clarity of the planetary model left me with a distinct impression that the fundamentals of physics was settled science. And I'm pretty sure most people leave school with the same impression. Physicists, on the other hand, have a very different impression. Let's return to the fabric of the cosmos to hear some of their reaction to aspects of quantum mechanics, which is the physics behind the quantum model.
It's almost impossible to picture how weird things can get down at the smallest of scales. Objects do things that seem crazy.
It's very mysterious why that is.
And that's just very strange, right?
Really peculiar.
That is highly counterintuitive and something which many people would find difficulty accepting.
Something so strange, so counter to all logical views of the universe. To understand how profoundly weird this is, so ludicrous, he called it spooky. Bayes' results are truly shocking.
Absurd, crazy, ridiculous, completely bizarre. It is impossible to even comprehend. Don't even ask me why. Don't ask me which you're going to, how it works, because it's an illegal question. All we can say is that is apparently the way the world ticks.
The very fact that our reality is much grander than we thought, much more strange and mysterious than we thought, is to me also very beautiful and awe-inspiring.
The beauty of science is that it allows you to learn things which go beyond your wildest dreams. And quantum mechanics is the epitome of that.
After you learn quantum mechanics, you're never really the same again.
And so the discovery of quantum mechanics has revealed a reality. our reality that's both shocking and thrilling.
So if our reality is described by physicists as shocking because it is made from shocking particles, then a revolution in physics is required to explain this behavior. And this revolution is likely to be truly shocking, highly counterintuitive, counter to all logical views of the universe, and all these other things, because that's the kind of behavior it is required to explain. In fact, the expected level of shock factor in the pending revolution in physics should surely increase with each passing decade that the shocking behavior remains an unsolved mystery. For example, the mystery of why particles seem to be in many places at once has been unsolved for nearly a century. This mystery is easily demonstrated using one of the most shocking and logic-defying experiments in all of science, the double-slit experiment. To understand this experiment, let's start off hypothetically with a marble shooting machine that is shooting marbles towards a pair of slits in a metal plate. A detector screen behind the slits displays a dot on the screen wherever the marbles strike. After an hour of marble shooting, a band of dots builds up behind each slit like this. Now let's take a look at an actual double-slit experiment, which involves much, much smaller components. It's performed not with marbles, but with electrons, which are 10 quadrillion times smaller than marbles. And the slits, in this case, are only a few micrometers apart. Now, if we shoot electrons, which are particles of matter, through these tiny slits, we should expect to see the same type of pattern on the detector screen as we saw with the marbles, right? But we don't. Instead, we see
one of the craziest experimental results in all of physics.
So says Professor Matt O'Dowd of City University in New York, who describes this as the quantum experiment that broke reality. Because the pattern that builds up on the screen is an interference pattern, the same pattern that would be made by water waves traveling through a double slit. This pattern results from the interference of two sets of semicircular waves that radiate out from the two gaps as the water passes through them due to diffraction. Science communicator Derek Muller demonstrates this pattern using two polystyrene balls bobbing up and down, and we can see how this corresponds to what appears on the detector screen. The shaded areas are the areas of constructive interference. Constructive interference occurs at those points where wave set 1 and wave set 2 are in phase. In other words, the crests and troughs line up with each other. As the two waves overlap, they construct crests which are twice as high. Destructive interference occurs at those points where there is no disturbance at all. This occurs where the two wave sets are out of phase. In other words, crests are lined up with troughs, and the two waves cancel each other out. If we compare the bands of constructive and destructive interference between electrons and water, we see a mathematically similar pattern. It seems as if each single electron must somehow act in the same sort of way as the combination of all of this water. This suggests that each single electron must take all possible paths at the same time, and these paths must traverse the slits in the form of a wave that interferes with itself. Then, when the electrons arrive at the screen, the universe randomly selects one location from all of the possible locations it could be in, but not completely randomly according to this probability distribution formula called the wave function. So the electrons seem to be doing this. This seems physically impossible. What theory could possibly explain how a single electron seems to multiply into a whole cloud of electrons, which interfere with each other and then suddenly vanish into thin air, leaving just one? Indeed, there is no consensual understanding of what happens in this experiment. And this leaves a critical question unanswered. What is a particle of matter? What kind of bizarre form of particle can do all of this? Is it a particle or is it a wave? It seems to be a combination of both. The fact that a single electron deposits all its energy in one spot demonstrates its particle-like nature, and the fact that a series of electrons produces an interference pattern over time demonstrates its wave-like nature. This is known as wave-particle duality. Since the fundamental building blocks of matter are an unsolved mystery, this leaves many other questions unanswered. What is matter? What is physicality? What is the universe? What is reality? And most importantly, what am I? These are all unsolved mysteries that arise from a science whose fundamentals have yet to be understood. As a result, the universe, and all of us, could be something completely different to what we have always assumed.
As we examine the fabric of the cosmos ever more closely, we may well find far more surprises than anyone ever imagined. Take me, for example. I seem real enough, don't I? Well, yes. But surprising new clues are emerging that everything, you and I, and even space itself, may actually be a kind of hologram.
The idea that the universe could be a type of hologram was embraced by the likes of Stephen Hawking, who was working on just such a theory when he passed away in 2018, though he was by no means the first to suggest it. This shows that the wave I'm referring to is not something new. It has been looming over our world ever since we discovered the shocking behavior of quantum particles back in the 1920s. We live in a world in which the fundamentals of physics are not understood. And when we finally understand the fundamentals of physics, we will finally understand ourselves and the world we live in. And I believe that after nearly 100 years of mystery, a problem as shocking as this will likely have a solution as shocking as this.
This idea is so new that physicists are still struggling to understand it. But if it's right, just as Newton and Einstein completely changed our picture of space, we may be on the verge of an even more dramatic revolution.
Does the pending revolution in physics involve a holographic universe? If so, what could we be made of, according to mainstream physics, that would allow for such a notion? And what could we be made of that would enable telepathy? That's what we'll explore in the next episode of Revolution of Reality. Credit and thanks for the double slit animation goes to the creators of this video from this website.